Hey, this is Digital Byte Computing. Today we're going to look at a data center. So we're going to go through all of these different cabinets, which essentially are the big, boxes that have got a whole bunch of network and servers and storage infrastructure in IT. So there's a whole different bunch of technology. So we're going to go through one by one. We're going to start with the servers and then sort of go through essentially all of the technologies that are inside the comms cabinets. We're going to touch on each one briefly and sort of explain what they do, maybe how they're cabled, how they're connected, but really just a real rough overview of what a comms cabinet within a data center contains. So let's look at that right now. So we've got some rack-mounted servers. So these servers actually go and rack mount in the actual length of the cabinet. We've got Dell ones, we've got HP. There's other manufacturers available. If we just take off the panel on the front of a server, so a lot of servers will contain like a panel just to protect. You've got, the brand, this particular is a 720, so it's a bit of an older Dell server. And then you've got your slots for your hard drive. So literally you've got a hard drive here that you can just pull out and then just slide in a brand new hard drive when you have a hard drive that is faulty, or if you actually want to extend the hard drives that are in here. So many rack-mounted servers will have an LCD display on the front, giving you some stats about the server, the health of the server, some other information that you can easily navigate through some sort of a button interface. You can actually sometimes adjust some of the settings that are displayed on the LCD directly from here. Such as the IP address, etc. You'll have maybe some sort of a tag that you can pull out that has information about the serial number. You've got a simple DVD drive, some USB ports. In this case, I've got a little maintenance thing here if you've got maintenance, say from Dell. And most servers also have a port here so you can plug in a monitor directly into the server to actually see what the server is seeing, whether it's the console, or the BIOS, or a Windows server if it's got Windows installed. The server cover generally will have some sort of a lock interface where you can put in a key and lock it. If you do have specific security requirements in your organization, you can lock it so that people who don't have access can't even actually access the box to log into the console or do anything that needs to be done. So this is the back of one of the cabinets, right? One of the comms cabinets. Now you'll see that these are essentially the back of the units. This is the back of a server with all of the relevant cabling plugging into it and going into their relevant positions, whether if it's the switches, routers, storage units, into other servers, etc. Now, most data centers will have what's called a cold and a hot area. So if you have a fairly large area, a large comms room, for example, you'll generally find that the backs of the units will face each other and the fronts of the units will face each other. This is to help with airflow. So in the current place where I'm standing, it's a lot hotter than on the front of the actual the comms room, right, in front of the data center room. So we've got some storage media here. So this is what's called a SAN. Essentially, it's just a big array worth of disks, right? So you've got your bottom one, which is where all of the brain sits, the CPU, the RAM, etc. And then you just got trays worth of disks, all right? So we can open one of these up. You can see it's essentially just full of disks. All right, so similar to the hard drives that you would have inside your computer or an external hard drive. These are what are called SAS drives. You can have these in certain speeds. You can also get flash-based for much faster speeds. And essentially, these are just trays worth of disks that you then share out to your server fleet, to your to your network. And you store your servers on these, you store data, etc. All right, so most data centers will have some form of physical storage. This is a SAN. You can also configure these devices as NAS devices, NAS or SAN, depending on what your requirements. Easily accessible by holding the side buttons and opening it up. They come in multiple brands. This is a Dell EMC, all right, but there's also HP, Cisco, other brands also do similar setups. So depending on your setup around backups, you may also have the need for some form of tape library. So this is a Dell tape library, pretty standard using LTO media. There are other brands, many other brands that also do tape libraries such as this. And essentially you've got your backups running onto tapes, and then they would then go off-site to some sort of secure facility where you can keep your backups for a certain amount of time based on your retention policies in your business. So this is rack mountable. It's connected at the back via your fiber and Ethernet connections, and then backs up onto tapes, LTO media, and off-site. So in most scenarios as well, on top of your tape library, you may actually have some physical storage. So these are the EMC Unity range of SANs or NASs, and our backups would then back up to some sort of storage, physical storage medium, and then onto tape from here. So these would contain a number of disks quite easily, exchangeable. You can just change the disks quite easily. You can open them up. You can put new disks. You can expand your media. So we've got some switches. So these are devices. These are Cisco switches, where essentially you're going to have devices such as servers, desktops, phones, storage units, etc. that patch in to the actual port on the switches. You've got things such as 10 gig, 1 gigabit ports. These are using RJ45 connectors. And then you've got the model of the Cisco switch like so. So essentially every single device to some extent will need to be plugged into a switch. These are called managed switches, which means they have their own, complex operating system available, where you can log in to these Cisco portals. These are running a software package and operating system called iOS, which is Cisco's operating system. Command line, where you can go in and actually, control what these ports do. You can set up the speeds. You can set up, particular trunks. You can set up VLANs. You can do a whole bunch of things. So an example of the switch here. So this is the switch that has RFP connectors. So these are essentially modules that you can purchase with different heads, all right? So this is a RJ45 for a Ethernet cable, or you can get RFP connectors like this one, which run for a fiber connector. And then literally you just patch this in to the port, and then you can run your cable in and then configure that switch accordingly. And you'll see that here we've got different colored cables. So in some scenarios you may want different colored cables depending on what sort of connection is going into that switch. So you may have management ports, data ports. If you have trunk ports, if you want to connect switches together, you may have a requirement for different color coordination depending on what sort of interface, what sort of data is going to be traveling through that cable and into that particular switch. Here we've got a wireless controller, like a wireless router, and then we've got some additional routers as well. So you're going to generally have some form of switching, some sort of routing, and some sort of firewall protection on your network to allow you to control your network security and which way your traffic is flowing. So some firewalls. These are Cisco ASAs, which is Adaptive Security Appliances, as you can see there on the bottom. It's got a hard drive built in, a number of LEDs so you can actually control and see the health of the system. But this is physical hardware firewalls that are done by Cisco. There are other manufacturers as well. You can use these to control what sort of access you get into your network via port security, IP security, etc. You can also go for software-based firewalls if you do want to go down that route. But sometimes firewalls that are hardware-based, so these are rack-mounted hardware firewalls, sometimes can be a little bit better because you have physical control of what's going through, because you've got physical cabling going through here, so it actually forces the physical traffic to go through your firewalls. So we've got some Cisco ASA, this is a 5516-X. This is what we use for our VPN connections, all right? So you can actually control your VPN connections coming in to your business. Not every rack will have something like this. You could have software VPNs in place, but in this case it's a hardware VPN that is rack mounted and screwed on the front here. So most data centers or comms rooms will have these things called cross connects or patch panels. Essentially you're going to run devices into these, and then these will physically go somewhere, right? They're going to go physically to a desk, for example. If these are patched in with computers, these are going to run behind a wall, through the roof, under the floor, to a computer on a desk somewhere. They could also run into servers, and in these cases these are running into other comms cabinets into another, actually, into another patch panel in another comms cabinet. So I can run, for example, a device into this port here, which is port number 4, and then in another comms cabinet, I've got another similar patch panel, and then I can run from 4, which we know is running from this one, and then connect essentially 2 devices together. This is a Ethernet RJ45 patch panel, and then we've got a similar one for our fiber connectors also. All right, so these patch panels are quite common. You're going to be using these for phones, for servers, for your desktop computers on your desks. They're going to be running into patch panels in comms cabinets, particularly if you have multiple floors, into patch panels into those floors, and then in some way they will then connect into some form of switching or routing network configuration. So here we have the inside of a comms cabinet. All right, so these are the rails where you actually are going to rack mount your rack mountable servers, switches, routers, storage units, etc. See that this particular one is numbered accordingly to know up to which number you're up to. Not all of them may be like this, but then you've got a simple switch like this one, which is just screwed into the back with a nut and bolt sort of configuration, and that is rackable into your actual comms cabinet. A lot of newer devices will have some sort of a clip system that literally just clips into place, so you don't have to fool around with particular nuts and bolts necessarily. All right? You can also use these, for example, in this scenario, I've got, this is just cable tied. I've got a whole bunch of cables that are just cable tied and fed through one of the holes to make my, my setup a little bit neater. But then you see that the rail just sort of goes all the way up, numbered accordingly, and then I just rack mount my servers, my devices, my switches accordingly. So these will be on the front and on the back of the comms cabinet, and on the left and the right, so I can put a full rail device straight in. I've also got power generally built into most newer comms cabinets. Some comms cabinets may not have this, so you may need to have additional power added. But you've got your standard, kettle cable sort of connector here that runs straight into a server for power, into a switch, into a storage unit, and these will be on the left and on the right. And you can configure this accordingly for redundancy. You'd have one going into the left and one going into the right. Because what you'll find is a lot of devices, a lot of newer server switches, etc., will have dual power supplies. So you can run one into the left-hand side and then one into the right-hand side, so that if one power adapter fails, you've got redundancy. And if a whole particular rail fails of power, you've got redundancy also. So you've got the other side just like so, nice and easily running connectors straight into the sides for redundancy or power. We've got a phone system here. All right, so this is going to be hooked up from physically coming out from the street, patched in, crimped in, croned, and running into some form of PBX system, a VoIP system, something that controls your telephony within an organization. Okay, so you've got here, your cables coming in, then there's split, and you see them coming in, and then they're crimped into particular ports here, and then running into their appropriate destinations. Now, certain cabinets will have plates set up like this. What this is for, essentially for airflow. So in these cases, there's nothing racked in these particular rails, okay? So what you do is, instead of leaving them open, you put a cover on it. Actually allows you airflow in terms of hot, cold, etc. And they're easily removable just by literally just popping them out. You can cut them to size and you can just place them back in there. Not every data center will have these, not every comms cabinet will have these or even need these, but it's always good to have it if you are concerned about things like power usage, how the air flows through your equipment. So there is my basic overview. So you're really looking at a whole range of different types of servers across multiple sorts of modules, such as your rack, your blade. You've got rack mounted servers. You've got systems which are called Hyperconverged, which essentially have got your servers, your networks, your storage all sort of built into single units. Those options are available if you don't want to fool around with all the individual components. You've got the Cisco UCS range, which would be an example of one of those. You've got other devices such as load balancers, which is part of your network infrastructure for load balancing your traffic. If you have certain websites that come in and you need to load the traffic accordingly between your systems. You've got things such as replication of storage. So you may have modules that their sole purpose are for disaster recovery. So you're replicating your data centers from one to another, to keep your data updated. So there's really a whole range of different vendors, different sorts of technologies that are available. Now, on top of this, most data centers and most comms cabinets will have some form of backup power. So we obviously looked at, physical power points where you can plug in all of your devices, but they in turn will run into some form of backup power, such as UPS or generators, whether they're inside the comms cabinets themselves or whether they're in some sort of separate area in a data center, perhaps in a basement or something similar. Now, you've obviously got to consider things such as cooling, having adequate air conditioning amongst, in your room, in the comms rooms, in the data centers themselves, making sure that the power, the temperature in those rooms are kept to a minimum to save, the longevity of those systems and to keep everything running at an optimal temperature. So that is my overview. So there is really a whole bunch of stuff that is available in data centers, in comms rooms, things like cable management, labeling everything. There's a lot of practices and policies around all this sort of stuff, which we can leave to talk about on another day. But look, I would love it if you commented below. If I did leave any architecture, any infrastructure out, I would love to know your thoughts. And look, I hope you found this helpful, and we'll talk to you next time. Thanks for watching. So if you found that video helpful, please like it and subscribe to my channel, Digital by Computing, just on the button there for more videos.